All right, everybody. Today we're going to be talking about how to solve exponential equations using logarithms, base 10 and base e. Something I want you guys to understand when you're dealing with base 10, that is referring to what's called the common log. And where you're dealing with base e, you're going to be dealing with a natural log. If you're wondering where those are on the graphing calculator, the common log is right here and the natural log is right here. So this is dealing with the base 10, this is dealing with base e. You can kind of see above it says 10 to the power of x and e to the power of x. So they're right next to each other. So we're going to be using those today. So it says consider the equation 0.5 or a half times 10 to the power of 8 times t equals 73. So we're going to solve for the equation t and we're going to express it as a logarithm in base 10. So I'm going to go over here and do a little work. Here we go. 0.5. Now, if you want to use a half, you're more than welcome to use a half. Times 10 to the power of 8 times t equals 73. Now, when I think of a half, all right, right there, you could divide both sides. Now, sometimes what students will do, they will try to multiply this half times this 10, and that will not work because this is not just a 10, it's 10 to the power of 8 times t. So that won't help you there. Okay? So what we need to do first is simply divide both sides by a half. So that's one way of doing it. Okay? Divide both sides by a half. But personally, what I like to do is if it's a half, instead of dividing both sides by a half, I like to multiply both sides by 2. So I'm just going to double that. Okay? For whatever I do to one side, I got to do the other side. So if I double this, that cancels out, and we're left with 10 to the power of 8t equals 146. Now, there's a couple ways we can do this problem, all right? And it's going to be helpful if you understand or know how to go from exponential form. For example, here's exponential form, like 2 cubed equals 8. And that is what's called an exponential model, all right? Exponential form. But a logarithmic form, so we can put log, we would write log base 2, 8 equals 3. So this is exponential form, this is logarithmic form. And a way to check it is just to go around the world. 2 to the power of 3 equals 8. 2 raised to the power of 3 is equal to 8. So we could actually rearrange this and help us solve the problem. All right, so see if we can do that now. Let's go ahead and take this. And another way of thinking about it is, let's say if I had b to the power of x is equal to y. If I wrote that in logarithmic form, that'd be log base b y equals x. So b to the power of x is equal to y. So let's check this out. See that 10 is the base, so I could, if I wanted to, I could write log base 10 146 is equal to 8 times t. That's one way you could rearrange it if you wanted to. And then if you wanted to solve for t, you could simply divide both sides by 8. And you're done. All right? So now here's the thing. This has base 10, but technically the common log is base 10. So literally you could rewrite it as the log of 146 over 8. And that's what they want for what's called the exact form. All right, I want that for the exact form. So let me type something into the graphing calculator so you know that these mean the same thing. So you believe me. So here we go. I'm going to go alpha y equals enter. I'm going to type in log 146 over 8 and press enter. There's the decimal. But I'm also going to do alpha y equals enter and then hit alpha window number 5. Put a 10 there, all right, base 10. Put an 8 here, and, oh, got to go up here. Oh, going the wrong way. Here we go. Type in a 146. And you see that these are the same thing, all right? But this is a more simplified way of writing because you need to understand that the common log, you don't have to put a 10 there. It's automatically assumed because we count in a base 10 counting system. All right. So these are the same thing, but this is the exact answer, and this is the decimal equivalent, and we're going to round it to the nearest thousandth in our problem. All right, we're going to round it to the nearest thousandth. So this is the thousandth. So since it's a 5 or higher, our approximate value is going to be 0.271. That's what I'm going to type into the Khan Academy. All right, so here we go. So right here, let's look at the exact expression. And I believe our exact expression, we're going to go over here to the old fraction, put a log. We're going to type in 146 over 8. All right. And then what do we get as our decimal? 0.271. All right. 0.271 because it rounded to the nearest thousandth. So 0.271. All right. Make sure I got everything right. Make sure I wrote it down right. Oh, let's go over here. Yeah, log 146 over 8. Just making sure. Log 146 over 8. There we go. Now, I told you that this was one way of doing it. Let me show you the other way that you can also do this problem. So, understand there is a specific rule dealing with bases. So, for example, if I say log base b, and b has to be greater than 1, b to the power of x equals x. This is a very important rule, okay? So what I want you to understand is if I write, I'm going to erase something real quick and give me a little bit more room on this side. There we go. If I apply what's called log base 10 on this side, I need to apply log base 10 on this side. Now, log base 10, you can also do it without actually writing the 10 there. But if these are the same, I can simply bring down the 8 and the t. And then here I can write log base 10, 146. But I don't technically have to write the 10. I can simply write 8t equals log 146. And then I divide both sides by 8. And I get the same answer. Okay. Do you have to write log base 10 right there and right there? No, you don't. You don't have to because that's the common log. But I want you to understand it follows this pattern, this rule, that when you have the same base, and I'll prove it to you. Okay, we'll just kind of... All right, so let's go ahead and go alpha window number 5. And let's do a 4. And then we'll go inside here and we'll do a 4. And we'll raise that to say 1, 2, 3. Oh, 1, 2. I like 1, 2, 3. Press enter. See? Same base. Whatever you type in there, you get the same number. All right? So it kind of makes sense if you think about it. All right? It's all about understanding patterns. All right? We're trying to help you understand the pattern. And if you understand the pattern, it works every single time. All right. 1, 2, 3 equals 1, 2, 3. If you remember around the world, 4 to the power of 1, 2, 3 equals 4 to the power of 1, 2, 3. That's another way of looking at it. All right, so there we go. We're going to go do another problem, except this time I'm not, every time I see common log, I'm not going to put a base 10 there. I'm just going to put log instead. All right, so let's go on to our next problem. Okay. Oops. Where is it? Oh, there it is. Okay. All right. Okay, now this one's a little bit different. We're dealing with base E, but that's okay. All right, not a big deal. We talked about the common log. All right, this is the common. Write the word common. This is dealing with the natural log. So something I want you to write. I want you to write log base E, e to the power of x is equal to x. Same base, power of x equals x. You could also write the natural log of e to the power of x is equal to x. Because these actually mean the same thing. They're the same. Okay? Now I'm going to prove it to you. All right? I'm going to prove it real quick. It won't take long. All right. So we'll go alpha window number 5. We're going to use base e right there. We're going to make that an e, and we're going to raise that to just a regular number called 5. And what's going to enter? It's going to be a 5. Boom. But I could also say the natural log. All right? The natural log of e to the power of 5 is 5. It's the same thing. So these mean the same. Okay? So when you apply the natural log to the letter e, you get the number 1 every single time, because technically that's to the power of 1. So it's like having a 1 instead of a 5 there. So that's how we get rid of Euler's numbers. We just apply the natural log to both sides. If you're wondering what Euler's number is, it's this number right there. Okay? And you get Euler's number. I'm trying to go off the top of my head. Let's see here. I'll put y equals, I'm going to do parentheses 1 plus, I could totally be wrong here. I'm trying to remember it off the top of my head. Smarter people than me would know it right off the top of their head. 1 over x raised to the power of x. And then I'm going to hit second table. Okay, except what we need to do is I need to make it a fraction. You know what? I need to make it a fraction so you can see it better. So you know what? I'm going to delete this. There we go. 1 divided by x. Close parentheses. This will make it easier for you to understand. There we go. Now check this out. You're like, what is Euler? What? That's not Euler's number, but check this out. As it approaches infinity. So watch what happens when I make a really big number, like 10,000. Look what it gets really close to. And it just stays. It just is an irrational number. So even if I put like 100,000. Yeah, 100,000. Look, there it is. So Euler's number is an irrational number that you get when you do parentheses 1 plus 1 divided by x, close parentheses. Oh, let's go ahead and change x to a really large number, like 1 million. Okay, 1 million. We're going to raise it to the power of 1 million. 4, 5, 6. And look what happens, people. It gets really close to Euler's number. Just kidding. That's like my Dr. Evil voice. See how these are very close? Okay, this is the actual approximate value. That's enough about Euler's number, but that's where base E comes from. Okay, so we're going to go ahead and solve this guy so you know how to solve it, because that's probably what you're here for anyway. So hopefully if you didn't like that, you could just fast forward, because you don't have to watch the whole thing. So here we go. Negative 3 times e to the power of 5w equals negative 88. So what we're going to do first is we're going to divide both sides by negative 3. That's the first step. Divide both sides by negative 3. And you get e to the power of 5w equals 88 over 3. Now I'm going to keep it as 88 over 3 because 3 does not go into 88 perfectly. Okay? Now, what do we do to get rid of e? This is what you do. You apply what's called the natural log to this side. And I have to apply the natural log to the other side. So I'm going to erase this real quick. I'm going to apply the natural log to the other side. Okay? Now what happens? Remember what I said? The natural log of e always equals 1. ln e equals 1. So these become a 1 and you're left with 5w equals the natural log of 88 over 3. Now you could divide both sides by 5, but personally, I like to multiply things by their reciprocals, which is 1/5. So I'm going to multiply this by 1/5. I'm going to multiply this by 1/5. These cancel out. And my final answer is w equals, it's beautiful, 1/5 times the natural log of 88 over 3. Now that's my exact answer. Now I believe the Khan Academy will accept this answer as well. Okay, so these are technically the same thing. This just says 1/5 in front. This has divided by 5. Now that's not the approximate value. I cannot do the approximate value in my head, so I got to go over here. Ready? So I'm going to do 1/5 times the natural log, and I'll do 88 divided by 3. Okay, which is this number right here. Now, if you wanted to, you could do alpha y equals enter, type in the natural log of 88 divided by 3, and then go down here and hit a 5, and you'll notice it's the exact same approximate value. Now, if we're going to round that to the nearest thousandth. See how that's a 5? We got to raise it. It's 0.676. So they probably is 0.676, and that's what I'm going to put here. Okay, we have 1/5 times the natural log of 88 over 3. So that's what I'm going to type. I'm just going to type in carefully. All right. All right. Let's check it out. Let's see here. All right. I'm going to put 1 divided by 5. Then I'm going to put natural log, and I'm going to put a parentheses and put 88 divided by 3 right there. That's going to be the exact answer. Okay. And then our approximate was a 0.676, I believe. 0.676. All right, nearest thousandth. Roll the dice. Boom. Nailed it. On to the next one. So we got another base 10. All right, we'll do 2 more. All right, so here we go. We got a base 10. So let's go ahead and do this real quick. This one's not going to take long at all because I've explained kind of what to do. We're just going to go through it fast. Ready? So you write 10. And you raise it to the power of 2z. That's supposed to be a z. It's not a very good z. Z over 3 equals 15. Okay? Now, if you ever want to get rid of a base 10, just apply what's called the common log to both sides. Now, you could also rearrange it. All right? But I'm just going to apply what's called the common log. I'm going to put a log right there. I'm going to put a log right there. These cancel out, and you're left with simply the 2/3 of z equals the log of 15. If I rearrange this as a logarithmic model, here we go, I would put log base 10 15 equals 2/3 z. But understand, log 10 15 is the same as just saying the log of 15 equals 2/3 z. So you'll see we get the same equation. Now, you could divide both sides by 2/3, but I'm not going to divide both sides by 2/3 because it's a fraction, and I like multiplying things by their reciprocal, which is 3 over 2. So whatever I do to one side, I got to do to the other side. Let's see if I can slip it in here. Ready? 3 over 2, and boom, that's my answer. Because these cancel each other out. So my final answer, in case you can't see it, is z equals 3/2 log of 15. And that's beautiful right there. That's my beautiful answer. Now what I did basically, all I did was multiply both sides by 3 over 2 and multiply both sides by 3 over 2, and you can see the same answer because these babies cancel out. I love this blackboard. It's awesome. Okay, so that's my exact answer. So what would my approximate answer? Well, that's why I got to get the old graphing calculator out. So here we go. 3 divided by 2 times, let's see, what do we got? The log of 15. All right, times the log of 15. Boom. 1.764. 1.764. See if I can remember that. 1.764. So that's approximately equal to 1.764. That's my nearest thousandth. So that's what I'm going to write here for the nearest thousandth. I'm going to write that as the base 10. All right, let's try it again. Here we go. So I had a little fraction. I had a 3 over 2. Then I had a log of 15. Okay, and that was the exact answer. And my approximate answer was 1.764. 1.764. 1.764. Boom, nailed it. Now if you mess up, you can kind of see how they do it. I mean, it looks like they get similar. So they basically got 3 times, so they got the same thing. Okay, they show you how to change things from exponential form to logarithmic form, all that good stuff. Okay. They just don't have my ridiculous, fun vocals, that's all. I mean, obviously, Khan Academy, he's the man, but, you know. All right, so here we go. Consider this equation. We got one more, all right? They called him Mr. Khan. Okay, -5 times e to the power of 10t equals -30. All right, so what's the first thing we got to do? Divide both sides by -5. You're absolutely right. I like your thinking. We're going to divide both sides by -5. Divide both sides by -5. We get e to the power of 10 times t equals 6. Okay, now how do I get rid of this e? Ooh, I know. Because the natural log of e is equal to 1. That's super duper important. So what are we going to apply to both sides? We're going to apply the natural log to this side. We're going to apply the natural log to this side. And that simply makes that equal to 1. We got 10t equals the natural log of 6. Now, being that's a whole number, all right, 10, you could technically just divide both sides by 10, but if you wanted to multiply both sides by 1/10, that's okay too. But this time, since it's not a fraction, I know technically you could write it as a fraction of 10 over 1, but divide both sides by 10, boom, that's what I'm going to type in as my exact answer, because those babies cancel each other out. So my exact answer is the natural log of 6 over 10. And my approximate answer is, what did I write down? The natural log of 6 over 10. Natural log of 6, enter, divided by 10, enter, 0.179, 0.179, 0.179. Okay, let's do it. 0.179. And our exact answer was the natural log of 6 over 10. Got it. Natural log of 6 over the number 10. Oh, I got 10. Good. Nailed it, 100%. That's how you do it. That's how you solve with base 10 and base e. Tomorrow we'll do other bases, but these are the very, very common. That's your common log, and that's your natural log. Hope that was helpful, and hope you're able to solve these with super ease. I'm done.